Hi kids! Yay! Welcome to Module 5. This is so exciting. It's always fun to start something brand new and different. Don't you get tired of doing the same thing? I do. So kind of tired of fractions and all that stuff. Looking forward to getting back to decimals and doing more of that later, but we're going to sort of take a turn and work with things kind of hands-on. If you have some blocks at your house, it's going to be the best. But the objective with the beginning of Module 5 is they just jump right in and say, let's explore volume by building with and counting unit cubes. Now, I mean, I'm sure they have good reason for starting with volume. However, I think in my experienced years that kids do better when they start with an understanding of what area is. And so there are these two concepts. Area is flat, and then volume is fluffy. And so our warm-up activity is really, it's in the book. They do actually in the teacher's guide encourage teachers to spend a few minutes talking about area. So, so I want you guys to take these good notes. So area is the amount of square units in a defined space. Now that sounds kind of crazy, but it just means that I could measure using squares of something. Like if I have a ruler here and a ruler here, what they're doing is they're creating a square shape. And so I'm measuring how many squares, literally how many squares. So area is flat. You would use that if you're going to have new carpet put in or a new sod laid out in your yard, or how much blacktop is out there on the playground. So another fun thing about area is that you have to label it correctly. Okay, now on a lot of the computer tests I've noticed they are labeling for you, which takes some of the challenge away from it. But I want you to remember that you have two dimensions in area. Okay, it's flat, like flat Stanley or which I've never actually read, but I'm thinking that this is a flat thing. So area equals length times width. And these two measurements, again, you're going to have the length of something and then the width of something. And it doesn't matter which one you call which, it just is that there are these two measurements. So area is length times width. And it's very simple, super simple calculation. If you have a shape of something, you multiply the two sides together and you have your answer. Label it with whatever word is there, and then a 2 as an exponent. We haven't really spent a lot of time with exponents, but exponents are going to be a tiny little number up in the right, not so tiny that I can't see it, so give me a break, but like half the size of your binder paper line, like pretty small. Your other numbers should be almost the full height of the line. That way it looks different. So if you have a shape that's given to you like this square, what they'll do is they'll say, okay, here's one number, go for it. Well, in a square, all the sides are the same. So you simply just take the 3 and multiply it by a 3, and then you get your 9 and you label it carefully. Now, back to volume, because that's the goal for today. So volume is the amount of cubic units in a defined space. And we're literally talking about cubes. If you happen to have any of these fun little counting cubes at your house, then that is what we're working with today. And we're going to be building things, and all you need is like maybe 24 of them would probably be enough for all the activities. Keep them away from small children. They are a choking hazard. So volume is a 3D measurement, three-dimensional. It's fluffy, it's puffed up, it's not flat. Okay, and it's got a different label. It's labeled in cubic units because these are cubes. And the formula, just like there's a formula for area, there's a formula to find volume, which is, we love formulas. You just plug the numbers into the formula. And so the formula for volume is to take the formula for area, which is length times width, which is basically the flat space at the bottom, and then also consider the height. Yep, here come my hands, whoop, right up at the camera, because height is that third dimension. So if you have the measurements, and you may have to calculate them at some point, you take all three and multiply them together. And so that's pretty easy. 1 times 2 is 2, and then if the height is 2, then 2 times 2 is 4. and notice the label with the 3 exponent. Now with that said, I have a little thing for you guys to do. And I want you to pause the video right here real quick and look at these shapes, okay, and calculate the area, just the area. Look, they're flat. So pause the video, calculate the area. I'll give you guys the answers in a minute, okay? Calculate the area. Ready, go. Pause. Now, we're also going to be drawing a wee bit today, and you'll be drawing some solids, and you have some templates in your workbook, your Learn book, and so I'll try to show you how to use those as best you can. I usually have extra copies here in my classroom, and if you can get any of those or print them from the online Eureka Math program, go ahead and print yourself 1 or 2 sheets of each. It is kind of nice to play around with them. Now, when drawing solids, you have to consider that they have faces. So you're going to be asked, how many faces do you see? Or how can you count the actual number of cubes because I see multiple faces? So when you are constructing things with volume, you may not see all the faces. Like this is what I call satellite view, okay? If the camera is right above it, how many actual cubes can you see here? And you might say, well, I can see, some of you guys are like, I can see everything. Okay, now here you can basically see 3. You can see the red, the green, the yellow. But if I remove the red and the green, there are 2 cubes underneath it. And so even if I remove the camera, what you want is to be able to look at these figures from different angles. And so that's going to be what the trick is for volume, is to see, well, what does it look like from here? What does it look like from here? And how many of these are there? I hope I don't turn off the video because I'm putting this back into the rack thing. Okay, yay. So, so how to draw. Now, if you don't have any of that dot paper, don't you worry. Here's how you draw a 3-dimensional box. First of all, make a nice square. Okay, then go about midway and halfway up the next line. Okay, put a little dot right in the middle, and then make another square that is about the same size. And you want it to kind of go right over the top. Now you can connect the corners of all these, and voila, you have a cube. Okay, so this is how you would start if you want. I used to do this all the time. I was like, ooh, we get to make cubes, and then I would have these parallel lines that would go off the back, and then I would connect them over here. So that looks like a solid figure. And again, just make a square and then parallel lines that go off the back and then close it off. If you want it to be like see-through, like a glass one, then you can show all the lines that go all the way through. Okay, and so that's another part of today. Now, here's where you can check your work and see if you got all the answers right on the area. Pause the video for checking. And we are going to be talking a little bit about this, but I want to get to the book because this has already been a long intro. In a regular rectangular prism, we're going to talk about regular and irregular. So like a prism is a fluffy figure with volume. Volume can be found by finding the area of the base, which is the length times the width, then times the height. That's what I was talking about with the formula. And so the base is going to be what you see flat. So the base here would be 4. But if something is opened out, like say a tissue box, and it's the square kind or the cubic kind, so if you open it out and you cut those edges, you could see that this would be 2 units high. So we do have a few different activities to do in your book, but if you don't have the cubes, it's just kind of a bummer. So here we have lesson 1, and it says use your centimeter cubes. So essentially what you want to try to do if you don't have the cubes is look at the faces and remember that one cube has many faces. So this is one cube. And then you start to see, okay, well, I can see the top, but I can't see the side. And I can see the top and the side, but I can't see the bottom. And so you have to just kind of look and see, well, I'm going to see many little shapes when they construct it. Back here, look, this is a gap. Okay, very important to notice those tiny details. And then on this one, well, what you have to ask yourself is, if these three up here on top are behind those first ones in the front, they have to be supported underneath by blocks that we can't see, because these blocks are not floating. Okay, so and the final thing that you can use with your explanations is that I always think of things that are stacked up as layers, like layers of a cake. Okay, and then this is also going to come in handy if you turn something and you look at it like this. This would be like slices of bread. Okay, so how many slices? And that's going to be your measurement. So 1, 2, 3, 4, 5, like 5 slices with 4 in each slice. And so once you get all these figures, then you can find the volume more easily. So it says construct them. If you do have your unit cubes, if you've got your supplies at home, then yes, do construct them. The more time you spend working with these blocks, the better. And again, keep them away from your little siblings and your pets. So figure A, the volume is 1. And we're going to label correctly. And so these are centimeters and it's cubed. So 1 centimeter cubed. Now, what's the explanation? Well, it's only 1 cube. Okay. And then for B, we go down. So you can build it. I have 3, and then it goes 2 high. Okay, so if I turn it so that it's kind of like the way that it's there, you can see that there are 3 plus 2 for 5. And so it's 3 on the bottom, 2 on the second layer, and write your explanation. Second layer. How about figure C? So this is 3 and then 3 and then 3. Okay, for a total of 9. Some of you guys that see these right away, it's going to be so easy. So it's a 3 by 3 or 3 across, and 3 high. So 3 times 3 equals 9. Okay, and then for D, now this is when they get into what are called irregular prisms. And so you've got the 3 across the front, but I also see one back here. And then I have another one back here. So the bottom is kind of like a U shape. And then there are 2 stacked up on this side, but not in the middle, and 2 stacked up on this side. Now this is what you might think would be like the hardest one because it is so irregular. You can count your 4 on either end and plus the 1 in the middle. So 4, 4, 8 plus 1 is 9. Or you can count them one at a time. And the explanation can vary. Basically, I'm just going to say 4 cubes on each end and 1 in middle. Okay. And then for E, this is what you call a regular prism, and it's going to be the 3 across, 3 behind that you can't see, but you got to build them anyway because you have 3 more and then 3 more. Now notice I did 3 and 3 and 3 and 3, and that's a total of 12. Now, this can be 4 columns, okay? You can do 4, 4, and 4. You can do it however you want. You are the builder. You could do 6 on the bottom and 6 on the top. Okay. It's whatever you see. And then for F, we have, again, if I talk about slices of bread, then there are 4 in each slice. So 4, 8, 12, and then build, build, build. And 20. Okay. And if I hold it up for you, then you can kind of see, although that one little guy fell out. Okay, so we have 20 centimeters cubed. And this is whatever you decide. You can say there's 10 on the top layer, 10 on the bottom layer, or you can do the 4 times 5. It's however you decide. Okay, so whatever makes sense for you. So now let's take these and turn the page, and let me show you what I'm talking about with these dot things. Now, it says build 2 different structures with the following volumes using your unit cubes. Then draw one of the figures on dot paper. One has been drawn for you. Before you go too far, my old book has homework in it too, so lucky me, but then if you skip a page, or you may have one right there, there's a template with this type of paper, and turn it again, and there should be another template with the dot paper. What I'd like you to do is section it off so that you have 4 opportunities to make different shapes if you need more space. Same here. Okay, really try to, too much coffee today. Did not get straight. And then straight across, so you have 4 chances to fiddle around with that paper. Okay, now back to the problem set. So when they say draw 4 cubic units, and we have this weird dot paper, what you want to do is, now on this one you want to make 7. So look at what they did. They went 1, 2, 3, 4. So if you want 7, go up a little higher. Go 1, 2, 3, 4, 5, 6, 7. Okay, now this is the front face. Now the hardest part is, where do I draw the connecting lines? So notice in the sample, we're going to go vertical for each cube face. Draw the vertical lines for the cube faces. 1, 2, 3, 4, 5, 6, 7. Now the trick here, this is where you turn the corner. This front cube has to have the corner of the cube showing. Vertical line for the far side. Now make this what the kids like to call a diamond on the top, but it's really just the whole cube. This is the only one where you can see 3 faces of the same cube. Okay, so if you need to, get a colored pencil and show this is one cube, and it is next to a different cube, but you see 2 sides of that one. Okay, so get colored pencils to help you. Now let's finish off this design. What do I do back here? Well, these are all pretty easy because they all go the same parallel way to the front base. Okay, and then the front, of course, is going to just come right down here. Now what? Parallel lines. Parallel. Close off the top of each one. Okay, and I have 1, 2, 3, 4, 5, 6, 7. 7 cubes. And if you, again, want to show that this is one cube here, then color 3 faces in on the end, and all the rest would get a different shade. Okay, and you can continue to do that on your own time. Now for 8 cubic units, if you would like to do them a different direction, you're welcome to, or you can make them a different shape. So what I kind of like to show is, well, we can make like a building, okay? And go down a little bit lower. Now I'm going to have a 2. Now this is where I'm going to make, instead of having it go boop, 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 boop all the way back, I'm going to have 2 blocks. Be careful about putting the top on, because when the top is what I say closed, it means you can't build up. So if I want to build up and I want to build from the base, then what I'm going to do is I'm going to do these V bases, okay, and then I'm going to go up the side, okay. So now I just built up a second layer. Look, no top. That's okay. I'm going to build up another layer. Okay, you can do little scribbles if you want. And a V at the corner. Look, V at the corner. Now I have 2, 4, 6, and I need 8. So I'm going to do the vertical lines. Close off that top face. But I also need to close the lid on the box so that I can be finished with this figure with 8 cubic units. So if I have 2, 4, 6, 8, I need to stop with the V. And it's the opposite. It's like an upside down V to put the lid on, and an upside down V to put the lid on. Okay? And that's where you have your 8 boxes. Now the only one where you can see all 3 faces is the top, right, front. Can't see the top of the bottom figure here. And you can only see the faces of 1, 2, 3 of these. So you can spend time learning how to color those so you can identify the 3-dimensional qualities of those. But anyway, that would have to be on your own time. So got a couple more little things. Joyce says that the figure below, made of 1 centimeter cubes, has a volume of 5 cubic centimeters. Explain her mistake. So you might say, well, 1, 2, 3, 4, 5. I see 5. There's nothing wrong there. But remember, this one cannot be floating. Cannot be floating. Okay, cubes don't float. So there is one way back there underneath that she can't see. Okay, so Joyce needs to include the one holding up the cube on the second layer. Okay. Sorry for the sloppy handwriting today. Not feeling too particular. So it can't be floating, and there needs to be one that's right back underneath. Okay? All right, so that's pretty clear there. And finally, imagine if Joyce adds to the second layer. So the cubes completely cover the first layer in the figure above. What would be the volume of the new structure, and explain how you know? So you can approach this many different ways, and you can say, well, I can stack additional cubes on what is already there, but don't forget that you already have one for the that's already there, okay? So if she has 1, 2, don't forget the bottom, 3, 4, 5, and then we need to add 1, 2, 3, 4 more because there's already this one here. Then if there are 5 on the bottom, there have to be 5 on the top. So the volume of the new structure would be 10 centimeters cubed equals volume of new structure. And then it's going to be 5 cubes for the base and 5 for second layer. Yay. Become a subscriber because we have fun like this every day. Okay? Love to help you guys out. Love to give you notes. Love to show you how to do this stuff. I know it's pretty challenging. So subscribe, and then you get notified every time I upload a new video. And welcome to Module 5. Yes! See you on the next one.